Thank you for inviting me. Well, you said my name already, Riccardo Marchesi. I represent as an SME, a small company based in Florence. The company was founded about 50 or 60 years ago to make textile machinery. These are some pictures from our archives. We had to stop about 12 years ago to make knitting machines because the market disappeared. So we had to reinvent our work. And to make a long story short, the company now produces 3 ranges of products. Metal textiles for EMI shielding, so protecting from electromagnetic fields. Something metal fabrics for interior design, and smart fabrics. We are particularly focused on fabrics for these reasons, because fabrics cover about 80% of our body, and they're everywhere in our homes and in public spaces. So they represent the best place to put sensors. These are just some ideas and projects regarding textile sensors, where they can help us and in which way. Now, this is a collection of, I mean, it's a presentation about all the different types of textile sensors that can be made. We're mainly focused on pressure sensors. For example, this is the schematic of a pressure of a pressure button. So it works exactly like a normal button, push button. It's made by 3 layers of fabric, and actually it's a 3D knitted fabric. There are 2 layers on the outside, on the 2 sides. They are conductive, and 1 non-conductive layer in between. And when you press the fabric, you basically close a circuit, and the current can flow, and the current flow is detected by a computer. It's completely biocompatible because the materials are acrylic yarn and stainless steel. Switch it off, please. Okay. These are the innovative aspects. The most innovative aspect is actually that the knitting machine produces the sensor as you see it. So there's no need of further production steps. These are some other advantages. They're flexible, they're transparent, you can put a light and you can see the light through, they're breathable, they let the air go through, and so on. With a similar technique, we can also produce liquid sensors, so sensors that detect liquids. You drip a drop of liquid on the sensor, and the sensor detects it. The first 2 sensors that we just saw are digital sensors. So they measure a level, so either high or low level. There's nothing in between. The sensors that we will see now are analog, so their output is a level, from a minimum to a maximum. This is an analog pressure sensor, so if you press it, the output of the sensor is a level, and it's the level of pressure that is applied. And this is an example that tells you what you can do with those sensors. This is a wheelchair developed for a person affected by cerebral palsy, and these are sensors that monitor the postures. There are sensors here that monitor the posture of this person. Strain sensors, so they measure strain, used also for rehabilitation. There was a sensor for this movement of the hand for people affected by hemiparesis due to a stroke. And this is a class of sensors which is a matrix sensor, and basically they work as a textile touch screen. So you touch the sensor, and the sensor gives you the coordinates of the point where you touch it, and the applied pressure. Some applications. This is an interesting project founded by the region Piemonte called FAPRE, Fall Prevention, and it's to help elderly people living alone in their houses. And there are some different types of sensors, like a camera or a Kinect, and a smart carpet that includes one of our sensors. And then there's a home server that collects all this information, and if someone falls down and is not able to get up again by himself, an alarm message is sent to a caregiver that then can take action. This is a very interesting application of one of our sensors in biorobotics done by Scuola Superiore Sant'Anna. This is a robotic arm that will drive an endocapsule, which is a capsule that monitors our gastrointestinal tract. And there's a sensor here, one of our sensors here, that will prevent the robot to push too much on the abdomen of the patient. It's used as a feedback unit. It's the first application of this type in the world, and this is a chart that compares all different types of sensors available on the market right now, and we are here, and we are one of the sensors. I mean, our sensors are some are able to give the best results in terms of easiness of integration and low cost. Also, there are two other advantages that we can make them in very big sizes, like 2 meters by 1 meter.
2 meters.
And they're also scalable to large productions. 2 words about textile actuators. In robotics, this is a social robot developed by the University of Siena to help autistic children in learning by playing. And we developed some soft interfaces for the robot, like this soft top cover that also is able to detect pressure. And so it's inviting for the children to play with the robot because they touch it and it looks like a small animal. And you can see it's a modular robot. We developed these 2 side panels, which are light emitting, and 2 types of top covers, the touch sensitive one and a very special one with moving hair. And this is a game that is called Scared. I mean, the robot goes in the scare mode. The robot can travel, and if the child approaches with a nasty attitude too fast, the robot goes back and it shows this scared face. Our future challenges is a deeper integration of electronics in textiles, and that's it. Thank you.
Thank you.